Welcome everybody to my web portion of this presentation. My name is Kat Edwards. I grew up on a dairy and crop farm here in Brandon, Manitoba. I've been building, selling all aspects of grain handling and equipment here in Brandon at Elton Agri-Sales for the past 5 years. Today my topic is going to be grain bin floors and foundations as they pertain to both wide core and hopper bottom bins. I should just mention before I get into anything here that the suppliers I'm going to be talking about have very specific requirements, and you should check with whatever dealer you're dealing with to check for specific requirements. Although lots of these products are very similar, specific requirements do differ from manufacturer to manufacturer. Some of the topics I'm going to be covering in this presentation are foundations, both for flat bottom and wide core bins, the concrete and gravel requirements as they pertain to both of them, partial floor systems, full aeration floor systems, specifications of the components needed for all these systems, and the importance of proper installation. First, I'm going to just talk about some hopper bottom foundations. There's been a big movement in the past couple years, not only in new hopper bottom sales, but as well as upgrading older bins into a hopper cone combo. Most foundation designs are based on a minimum soil bearing capacity of 3,000 pounds per square foot. The thing to keep in mind with this is that's not a standard for commercial tanks, just for average size hoppers. So you're looking in the 3 to 8,000 bushel hopper range. The foundation site must be totally free of vegetation and debris. The foundation must be found below the frost line. This is really important, and if you're not going to follow this, you're going to want to at least have 1 foot base of grade A gravel. Grade A gravel is especially important for compaction and drainage. It's made up of crushed rock and clay. All materials, again, should be grade A gravel for both the fill and the base. And concrete must have a minimum of 3,000 psi at 28 days. And again, that's a pretty standard measurement for concrete. Now the actual depth and amount of rebar needed for each hopper base foundation varies greatly depending on the hopper height, the diameter, what you're going to be storing in. I do have charts with me if anybody needs specifics on any size of bin. Now as far as anchoring bolts, we do see a lot of these bins being anchored directly to concrete without a skid. Typical sizes of anchor bolts, you're either going to be using a 5/8, 3/8, or a 3/4 inch. Again, a total variant on the size of the bins. And every dealer does have different requirements as it pertains to their own bins. Now you can use either a cast-in or a drill-in anchor. What we have been seeing over the last couple of years is a lot more bins being put on double skid. I guess the major advantage of this is that you don't need a concrete foundation, so your bin is mobile, it's sellable if you don't need it anymore. Same sort of requirements you're going to look at if you're going to be putting it on a double skid. You're still going to want to make sure you have a soil bearing capacity of at least 3,000 pounds per square feet. Again, ensuring the site is free of vegetation and debris, and you're still going to want at least a foot of a packed grade A gravel to provide a solid foundation for that. The more difficult challenge is when we look at upgrading older bins into hopper cone combos, and it is becoming increasingly popular. And the biggest question that we get asked is if they can use their existing concrete foundation to anchor the build directly to the concrete. 9 times out of 10, this is not the case. You're going to want to make sure you check the concrete requirements of that hopper, make sure that the hopper can take that extra load bearing capacity. But again, hopper foundations for hopper cones are a different foundation than a wide core bin, so quite often it doesn't meet the requirements and we end up using a double skid anyways. Next thing I'm going to be talking about is flat bottom or wide core foundations. Many of the same requirements apply when we're talking about wide core bins. The one major difference is you want a higher soil bearing capacity just to accommodate the larger style bins. So you're going to be looking at about 4,000 pounds per square foot soil bearing capacity. The foundations must be uniform and level. This is extremely important, especially when we look into putting support systems and full aeration floors onto the pads. You're going to want no more than a 1/4 inch variance as a guide over a 4 foot span. You want to choose a site that is well drained. You want to use 8 inches to 2 feet of packed gravel before you start your foundation. And you want to camber the outside edges of your foundation to make sure that water drains properly. Once again, as far as the depth of the concrete and the rebar required, they vary so greatly from bin to bin that you'll have to come see me after if you want specifics. But typically for a bin that's 10 to 40,000 bushels, you're going to be looking at a minimum 2-foot foundation, anywhere from 6 to 10 inches as a depth of concrete on the top, and 1 foot on the side walls. Again, anchoring these bins down, you're going to use either a 3/8 or a 5/8 anchor. Again, that's contingent on what supplier you're dealing with. Lots of suppliers do supply a skirt kit with their bin with pre-punched holes, so at least you know how many anchor bolts are required. Now, a lot of my counterparts here have talked about some partial floor systems as far as above ground system goes, so I'm not going to go too much into the duct systems that are above ground, but I will touch on a duct system that I call a flush Y system. It's known by different names, but it's an in-concrete system that's shaped either like a T or a Y. Now, it's an excellent solution for a smaller capacity grain bin. That being said, they are designed in a way that it can handle larger capacities. We just don't see it that often. Typically anything now over 8 to 10,000 bushels is going to see a full air system going in. When you look at these systems, it's probably going to be a new construction system that you're going to be putting these in. Because it's in concrete and there's extensive concrete required, you're not going to want to try to put one of these systems into an older bin. The major advantage of these systems is that there's no wasted space. It's an in-ground system, so you're not taking any bushel storage away from the top. There's easy removal of crop, and it can accommodate a clean-out system. Also, it does, like I said, support various depth levels. And I guess one of the more important things is that it's available in 0.05 perforation, which we can see in all the materials here, and I'll go into a little bit later. But 0.05 perforation is typical for canola storage. Now, these systems are mainly used for low airflow or drain dry applications. One thing to think about is that it's a permanent fixture. So if you put one of these systems in, it is difficult after to change that system. Before I go into the other floor systems, I'm going to touch really briefly here on the floors, the planks for the floors and the supports for the floors themselves. First, going into the planks, now every brand is different again. Your planks are going to range from a 5-inch, 7-inch, 10-inch. Again, that's going to be contingent on your support systems and what type of supports you're going to be using. There are a few commonalities between all the different suppliers and all the planks. All the suppliers use a 0.5 perforation as an option. You can get different perforations. You can get a larger hole perforation or a slip perforation. But again, 9 times out of 10 we see this one going because it is available to do canola, but it can also accommodate other seeds. Now these floor planks are offered in 18 and 20 gauge. 18 gauge support higher depths and 20 gauge for lower depths. One thing to think about when you're putting these floor planks in is if in the future you're ever going to be adding extension tiers to your bin, you're going to want to look at the gauge of plank you're putting in initially and make sure it can accommodate those extra depths. Perforated flashing has become almost an industry standard now. The flashing tapers to the outside of the bin on the floor and is perforated for even airflow. There was a time when it was straight metal flashing and you would have dead spots in the bin. Now both the flashing and the floor panel are corrugated, and this is what gives them both their strength. Now again, like I said, these planks are available in 7, 5, and 10 inch, and again it's going to be contingent on the floor supports, which I'll go into now. Now these floor supports are known by different names. I'll speak to them as I know them, but the names are going to change contingent on the supplier again. But the basic design of them doesn't change too much from supplier to supplier. The first is a channel lock system, or a U system, how I call it. Now these systems support 5 and 7-inch flashing. They are available in different heights. They're corrugated for their strength. As you can see, they have a different rib And again, from supplier to supplier, they do change, but that's how they do get their strength. And the holes in them are designed a specific way for even airflow and air distribution. They do lock to every plank, so every support does lock to every plank. Now, when you're considering the height of these supports, you're going to want to take a few things into consideration. You're going to want to know if you're going to put an unload auger in your bin, or if you're thinking about putting an unload in the future. With typical unloads, we see you need about 13-inch clearance, and there are supports available to accommodate that. Let's put these aside here. The next support I'll talk about is a welded support. Now, it's again known by different names through different suppliers, and the design does change a little bit from supplier to supplier, but the basics of it are the same. I guess the main advantage, just by looking at it, is the absolute open distribution it has. They're very strong, but it allows for open airflow. Now, the angle iron base and top of them is excellent for support. They're a superior strength system, and they're built to handle not only high depth volumes, but the repeated unloading and loading of an auger. One thing I should mention is, just by looking at them, they have a larger length and they cover a larger surface area. What this also does is accommodate for the inconsistencies in the concrete. So if you do have a small dip in the concrete, these are more able to deal with that better than the channel lock system. And I'm just going to go into some of the different floor systems available. First, I'll talk about circular and square pack floor systems. Square pack or T floor systems, they're known by different names. Now, they're both very similar systems in that they're flush systems. So again, this is something we see in new construction projects. They are in-ground systems. So the concrete work is done before, and then the floor is put over top the concrete, and it's a flush system. Major advantage, again, is no wasted space. So you're not going to lose any storage. It's easy clean out. They can both accommodate unload augers. One thing I should mention, although a little bit more expensive, circular floor systems, they tend to have a little more air coverage than the square floor counterparts. This is mostly due to the fact that a circular air system can accommodate 76% of the floor on average, so you're just going to get a more even air distribution. It also does a little bit better with the weight distribution of the bin. Lots of times in older bins, depending again on the capacity of the bin, we see square pack floors tend to fail around the corners, and it's either the concrete or the floor itself that fails. I should note though, both systems are available in many different levels. The Circ system in particular can accommodate bins up to 50,000 bushels. It's not something we see often. Typically anything over 10,000 bushels is always a full aeration floor these days, especially with new bin projects. Now I will go into full aeration floors. Now, the obvious disadvantage of a full aeration floor is that it's an above ground system. The only disadvantage being that there's wasted space, but the trade-off is well worth it. The full floor system delivers maximum airflow. There's no dead spots. It's a high performance system whether you require full volume conditioning or just natural air drying. Full floors are best suited to withstand the highest vertical loads. Not like their partial floor counterparts. They can support eave heights of up to 100, 150 feet or even greater depending on your support systems. One of the advantages from a contractor point of view is the ease of installation. I mean, a full floor system is the easiest by far to install, and there's no extensive concrete work to be done. Going installation. Now, installation methods do vary from supplier to supplier. You're really going to want to make sure you check your installation manual and not deviate from that manual in any manner. Every manual is going to include a support layout chart. It's going to tell you how many supports you need in your system. Again, this is going to be totally contingent on the size of the bin and the height of the bin. For instance, a 36-foot bin, if it's 8 tiers tall, is going to have a different support layout structure than if it's 36 foot high and only 6 tiers tall. So you're going to want to make sure that that's correct and you're following it precisely. It's going to tell you how far apart to space these support systems. Again, whether it's channel lock or whether it's a welded support system, it's going to tell you how far. It's also going to tell you what amount of hangover you're allowed. So if you have a support here and you have a sheet going over top of it, you're not going to want too much hangover, or else your floor is going to be compromised. Other things included, I mean, there's splicer flashing. Everything's perforated now. The splicer flashing is perforated. The flashing for the outside perimeter of the bin is perforated. Couple things that do sometimes get bypassed and to think about, especially with the flashing. When you're laying your flashing down, you want it overlapping in a way that's consistent with how you have your unload auger going. So if your unload auger is moving in this direction and your flashing is lapped like this, you may not see a problem right away, you may not see it in the first year, but over time it is going to start rubbing and the flashing is going to wear. Just little things like that are things to look out for. Again, you're going to want to check for a level base. It's one of the most important things for the consistency of your floor. Inconsistencies in the concrete are the cause of so many problems when we go out to these sites, whether they're new pads or whether they're upgrades from existing pads. Check for gaps in the concrete and make sure any of them are remedied. Now, as far as cutting holes in the bin for your unload auger and your transition for your fan, just make sure if you're not cutting on a seam, if that's where the fan's going, make sure you're cutting in between stiffeners. And that's all for me here. So I'd like to thank everybody for taking the time out to share some of this information with you. I hope it was relevant to your operation or that I've taught something new to you. Thanks so much.